Hi friend, welcome to your YouTube channel that is Civil Engineering Choice, and we know that already we have started the series of calculation of shear force and bending moment diagram of simply supported beam. Okay, so in that we have already covered some standard cases, and today we are going to discuss the next standard case that we will see. These are the topics that we have covered in last few videos, that is definition of beam, then types of supports and corresponding reactions, sign conventions for the shear force and the bending moment, and if you were to calculate the horizontal and vertical forces, so what will be the sign conventions that we have considered. Then definition, what is mean by shear force and bending moment diagram, that also we have covered. Then differential equations for the equilibrium means for the beam element. Then we have gone through that the general steps that we need to use to calculate the shear force and bending moment and to draw that particular diagrams. And we have covered few basic standard cases regarding the simply supported beam with the central point load, eccentric point load, then uniformly distributed load, then uniformly varying load. And today we are going to discuss about the simply supported beam carrying a moment at the center, or we can say the couple at the center. Okay, so this is the standard case that we are going to consider, and this is our fifth case that we are going to discuss today. Okay, so we know that for the calculation of shear force and bending moment, or to draw the shear force and bending moment diagram, first we have to calculate the support reaction, then we have to calculate the shear forces at each point, and third step to calculate the bending moment at each point. And for the calculation of support reactions, we are using three equilibrium conditions, that is summation fx is equals to 0, second summation fy is equals to 0, and third summation m is equals to 0. Okay, but out of these three equilibrium conditions, we can use only these two equilibrium conditions, that is summation fy equals to 0 or summation m equals to 0, because that summation fx is equals to 0 is for the horizontal forces. Summation fx means what? Sum of algebraic sum of all horizontal forces. Okay, and if you see in this diagram, there is no any horizontal force or a horizontal reaction. So if we have not used this equation for the equilibrium for the support reaction calculation, so that will be okay. We can calculate support reaction for this case by using summation fy and summation m equals to 0. And out of that, first we are using first equilibrium condition, that is summation summation m is equals to 0. Okay, so let's start with our steps. The first step is to calculate support reaction. Okay, so for the support reaction, first equilibrium condition, summation m is equals to 0, and we are taking moment at a point. Okay, that's why we have written over here summation m a is equals to 0, means we are taking moment at a point. And already we have discussed that what is mean by moment. Moment is force into perpendicular distance. Okay, moment is what? Force into perpendicular distance. And if you see this diagram, in this diagram we can see three forces. Okay, the first force at Ra, that is support reaction, we can consider this is Ra. The another reaction at B point, that is Rb. So these are the vertical forces which are going upward, and one force, or we can say couple, is there, that is M. Okay, kilonewton meter. So as we discussed, the force is what? Force movement is what? Force into perpendicular distance. Okay, but now if you see at C point, let's say this is C point, and at C point we have considered the bending moment. Okay, so in the calculation of movement, we not need to consider, or do not consider, the moment into perpendicular distance, because the actual definition of moment is what? Force into perpendicular distance, not moment into perpendicular distance. So whatever moment is given in your numerical, we can consider that moment as it is. No need to consider perpendicular distance while taking the moment. Okay, so if you consider over here, and again one more thing, while applying equilibrium conditions, first we need to consider the sign convention. And in previous numericals, we are the standard cases, we have considered clockwise movement as a positive. Okay, so same sign conventions we are going to use over here. So we can see that moment at C point is acting as a clockwise, correct? It acting as a clockwise, so we will take that moment as a positive, so it will be M, and it is positive. And then another force is Rb, and the perpendicular distance of that Rb is L from the A point, because we are taking moment at A point. So the moment will be Rb into L. Okay, moment at A point for this RB reaction is RB into L, and the moment of that RB is anti-clockwise, so we need to take it negative. So M minus RB into L, that is the moment at A point. And one more force, that is RA is there, but RA is exactly passing from the A point, so perpendicular distance is 0, so the moment of RA will be 0, so no need to consider movement of that RA. So we'll see what happened. So just take the moment M minus RB into L. So here we can see plus minus is there, and here we need only reaction. Okay, so that's why we can take M is equals to RB into L. Okay, so we can equate this equation. M is equals to RB into L. So RB into L is equals to M. So MB is equals to M by L. Okay, so the first support reaction that we have calculated at B point, that is RB is equals to M by L. Okay, RB is equals to M by L. Now apply another equilibrium condition, that is summation Fy is equals to 0, and calculate another support reaction, that is RA. Okay, so summation Fy means what? Sum of all vertical forces is equals to 0. Sum of all vertical forces. So here we can see only two forces are, that is RA and RB. Only two forces are there. So in the summation Fy, we need to consider only two forces, that is RA and RB. Okay, so just apply equilibrium condition. Okay, so summation Fy equals to 0. So RA and RB both are upward, so take a positive. And again, while applying summation Fy, we need to consider the sign convention, and already we have decided that if force is going upward, then we are considering that force as a positive. So here RA and RB, both force are going upward, so consider RA plus RB is equals to 0. But already we have calculated the RB, where RB equals to what? M by L. So just put that value, RB is equals to M by L. So the equation will be RA plus M by L is equals to 0. Okay, so now here we require RA, so just take M by L on the right side. So the equation will be RA equals to minus M by L. So here we have calculate the support reaction at A point and at B point. So where the support reaction at A point is minus M by L, and the support reaction at B point is M by L. Okay, so support reactions we have calculated, means first step that we have covered. Now in another steps, just find the shear forces, and for the shear force, again the most important thing is what? We need to consider the sagging and hugging concept. Now see the difference for the calculation of shear forces and the support reaction. In the support reaction we can use any sign convention. Okay, but for the calculation of shear force we have to go with the sagging and hugging concept, and already we have discussed it, how we are going to consider that sagging and hugging sign conventions for the calculation of shear forces. Okay, so I will give the link of that video in the description box, so just go to that link and just see the basic parts, how we have covered it and how we are going to consider the sign convention. Okay, so these sign conventions we are considering means clockwise couple. Okay, clockwise couple, and clockwise couple we are considering positive, means just take the section between that force. It means if your force on left side of a section and the direction of force is suppose upward, so we are going to it as a positive, and if the force is downward on the right side of your section, so we are going to consider it as a positive. Okay, and in previous problem statement also we have started our calculation from left to right for the simply supported beam. Okay, from left to right. So here also we are going to use the same method for the calculation of shear forces at each point. Okay, so now while calculating the shear forces at each point, what we are going to consider? We are calculating that shear forces at the each point. Okay, shear forces at the each point. Now here we have the A point, C point and B point. So we need to calculate the shear forces at each point. So what we have to consider for C point, that we will discuss. Okay, but now first need to consider the shear force at C point, and again we have to calculate the shear force first by taking section on left of A point. And if you take the section on section at the left of A point, and if you focus on left of that particular section, why left? Because we have started our calculation from left to right? That's why always when we have considered the section, then we have to focus on the left side when we have started our calculation from the left to right. Okay, and when you started your calculation from right to left, in that case we need to take the section on the right part of the point and then focus on the right. Okay, but for the simply supported beam, just go with this step, or we can say this method, for the calculation of every numerical for the shear force and bending moment diagram. Okay, so now a point we have considered, then we have considered the section left of a point, and then we are focusing on the left. Okay, so there will be no any force, so we can say that shear force a left is equals to 0. Shear force a left is equals to 0. Now next, after that, just take the section on right of a point, so we can say shear force a right is equals to, now see, if we focus on left of that particular section, okay, this section, so we can see one force Ra, and that Ra is upward, and as per our sign convention, if any force left of that particular section and the direction of that force is upward, so we have to consider it as a positive. Okay, so Ra already we have calculated, where Ra is what, m by l minus m by l. So shear force at a left is what, minus m by l. Correct? Shear force shear force a left a right is m by l, that is minus m by l. Why minus m by l? Because Ra is in minus. Okay, now the next point is C point, and if you see at C point there is no any force. Okay, at C point moment will be there, and the shear force is what, it is just a summation of forces. Okay, summation of forces. So where the couple is acting on the beam, at that point no need to consider the shear force and left and right part of that particular point. Okay, so we can ignore this point, directly go to the B point. Okay, now again at B point take a section on left. Okay, then focus on the left of that particular section, so we can say that shear force B left. Okay, shear force B left, and if you see in the left part of that section, only one force is there, that is Ra, and again Ra is upward. So for as per the sign convention, Ra should be considered as a positive, but Ra is what, Ra is minus m by l. So the shear force B left is minus m by l. Okay, minus m by l. And now again take the section on right of that B section and then focus on left. Now two forces are there, that is Ra and Rb. Okay, so we can say that shear force B right is equals to Ra upward, take positive, and Rb is also positive because of upward. So Ra magnitude is minus m by l. Okay, and Rb magnitude is m by l. Okay, here we have calculated Rb equals to plus m by l and Ra equals to minus m by l. So plus minus m by l will be 0. It means the shear force B right is equals to 0. Okay, so here we have calculated the shear forces at each point. See again. Okay, the shear force A left 0, shear force A right minus m by l, shear force B left is minus m by l, and the shear force B right is 0. Okay, so here we have calculated the shear forces at E points. Let's see. Shear force A left 0, shear force A right minus m by l, already we have calculated. Shear force B left Ra minus m by l again, and the shear force B right is Ra plus Rb, that is minus m by l plus m by l is equals to 0. So all points that we have covered, okay, means we have calculated the shear forces at each point, means shear force calculation, that is second step has been over. Now the next step is what, to calculation of movement. Okay, so let's go with the next step and see. This is the shear force diagram. So see, A is going up downward because it is minus. So here we can see this is our baseline. Okay, this is our baseline. If shear force is positive, so it should be, or it will become up of that baseline, and negative down of the baseline. So here Ra reaction at A left. Okay, A left is 0, but A right is what, minus m by l. So यहाँ से यहाँ तक क्या होगा, minus m by l. So it is minus, so going downward. Okay, now after that from A right to B left, it is constant. Okay, so A left to B right, it is constant, but B left it is constant, and B right it is 0. It means we need to close it up to the B point. So this is the shear force diagram when the simply supported beam carrying a centrally moment, or we can say the couple. Okay. Now next step. The next step is what? The calculation of bending moment. Okay. And already we have discussed, while calculating the bending moment, we have to calculate the bending moment at each point which are available in our beam. Okay. So here we have A point, correct? We have C point and then B point. It means we need to calculate the bending moment at each point. Okay, bending moment at each point. But one thing is, remember, listen carefully, one thing we need to keep in mind while calculating the bending moment, and if our any beam is subjected to a moment or couple. Okay, if any beam is subjected to a moment or couple, in that point or on that point, we need to calculate the moment at left of that portion or that point and right of that point. Means here we need to calculate the moment C left and moment C right. Why? Because moment is acting there, and due to that moment your bending moment diagram will suddenly change at this point. Okay, same as a shear force diagram. See what we are doing in the shear force diagram. When the force is acting at particular point, okay, when any force is acting at a particular point, let's say C point, so we are calculating shear force at C left and then we are calculating shear force C right. Why? Because shear force is there or the point load is there, and due to that point load the shear force diagram will suddenly change. Okay, similarly when the any point is subjected to a moment, in that case we need to calculate the moment at the left part of that particular point and right part of that particular point. Okay, so let's start with the moment calculation. And now all other points, let's say A and B, these are the normal forces are acting at that point, so we can directly take the moment at these points. Okay, so first take moment at A point. Okay, so sign convention already we have discussed it. Okay, means just take the section in between that. Okay, and if any movement means clockwise movement on the left of that particular section, so it should be positive. Okay, and we have started our calculation from left to right, so we need to focus on the this movement only. Okay, only this movement. Okay, so let's start with the calculation. So movement at A point. Okay, movement at A point is 0. Okay, why? We are taking the section at A point. Okay, we are taking section at A point, and if you focus on left of that particular section, so there will be no any force, so moment at A point will be 0. Now after that take a moment at C point, but as we discussed we need to take the moment left of that particular C point, so that is moment bending moment C left. Okay, so now C in the C left. Okay, if you take the section at the left part of that C, and if you focus on the left part of that particular section, only one force is there, that is RA. Okay, so moment of that RA is what? RA into perpendicular distance, that is L by 2. But RA is what? Already we have calculated. RA is support reaction, and the magnitude of that RA is minus M by L into L by 2. Okay, minus M by L into L by 2. So we can say L get cancelled, and the remaining term is minus M by 2. Remaining term is minus M by 2. See, the movement at C left is minus M by 2. Now similarly we can calculate movement on C right. Okay, so what will be the movement at C right? Okay, movement at C right, and if you take a section on right part of that C point, and if you focus on the left, okay, so here we can see RA force is there and movement is also coming over there. Okay, now be a movement behind. Okay, see, we are taking section at this point and we are focusing on the left part. Okay, so here we can see RA and that movement is also there, so we need to take that moment in the calculation. So moment C right is equals to, okay, the moment of RA is clockwise, so RA into perpendicular distance L by 2, it is positive, and then this moment is again positive because of clockwise movement. Okay, ये भी क्या हो रहा है? Clockwise movement हो रहा है, so it is again M, but no need to consider the perpendicular distance because already it is M. Okay, so RA already we have calculated. What is RA? RA is minus M by L, so minus M by L into L by 2 plus M. Okay, and here we can see LL get cancelled. The remaining term is minus m by 2 plus m. Okay, so minus m by 2 plus m, it is m by 2, positive m by 2. So the moment C right is plus m by 2. See, RA into L by 2 plus m, RA is minus m by L into L by 2, LL get cancelled, remaining term is minus m by 2 plus m, and the uh, bending moment C right is m by L. Okay, now the next is what? Bending moment at the B point. Okay, directly take the moment at B point, and if you focus on the left part of that particular section, so again two forces are there. One force is Ra and the another is a moment. Okay, so moment of Ra, again Ra into perpendicular distance. Now perpendicular distance is how much from the B point? It is L. Okay, then it is positive because of clockwise, and similarly moment is also positive because of clockwise. E is equals to, now we'll see what happens. Okay, Ra is what? M by L. Okay, into L plus M. Okay, so now L will get cancelled, remaining term is minus m plus m is equals to 0. Okay, minus m plus m is equals to 0. So moment at B point is equals to 0, and obviously if simply supported beam is there, so at the simple support your bending moment should be 0. So see, here we have calculated the shear forces at A point and B point, and then we have calculated the bending moment at A and B point. Now we have to draw the SFD and BMD. For SFD and BMD, just first draw the baseline. The shear force at A point is downward, so it will go downward. Okay, now it is constant from A to B, so it will be constant from A to B. Okay, it is constant. It is constant from A to B, and at B point it is 0. Okay, similarly we need to calculate we need to draw bending moment diagram. For bending moment diagram already we have calculated over here. At A it is 0. Okay, so this is our baseline. Okay, first baseline A is 0, so it is starting from 0 point, and at C left it is minus m by L, so it will goes down minus. Okay, it is minus m by L, so it is downward direction. Okay, see, it is in downward direction. Now again at right of C point it is plus m by L, so it should be go upward. Okay, so it should be upward, and from C to B it is going to 0, so it is 0. So this is the shear force and bending moment diagram. Here again you can see. Okay, again we can see it. Okay, baseline for the shear force. Okay, baseline for the shear force, then downward at A point, then it is constant up to the B left. Okay, constant up to the B left, and at B it will be the close. Okay, now the baseline for the shear bending moment diagram. Okay, then C left it is downward. Okay, C left it is downward, and C right it is suddenly goes up, and again from C right point to the B point it is 0. So this is shear force and bending moment diagram. Okay, so now see, this is a 6 case that is simply supported beam carrying eccentric point load, and if that eccentric point load is there, we need to calculate again shear force bending moment diagram. Okay, so just calculate the support reaction, then draw the shear force and bending moment diagram. So I am giving this example for you, so just solve it. Okay, and just try whether your shear forces and bending moment diagram it matches to me or not. If you face any problem, so you can write your question in the comment box, so I will answer it. Okay, so let's say this is our shear force diagram. Okay, it is shear force diagram, same shear force diagram as we discussed in the last video, the last statement, not video. Okay, and this is bending moment diagram. Okay, so we have to follow this. Okay, so hope you understood it, how we can solve the bending moment and shear force diagram. Okay, now this is for the eccentric point load. Just I have taken another one. Okay, see, it will be vary as per the condition. Okay, Yeah, so just go through that, solve it, and if you face any problem, then we will discuss it. Okay, so thank you everyone for listening me. And again, most important thing for me, if you are really getting knowledge from this video, so please share, subscribe my channel, and like this video, and click on the bell icon so you will get the notification of my video. As we discussed, we have started the shear force and bending moment diagram, this first topic, and we are going to upload all the videos which are related to structural engineering subjects like engineering mechanics, strength of material, structural analysis, design of reinforced concrete structure, design of steel structure, then design of preset structures. And then I am planning to upload some videos which are related to softwares like StatPro, ETAB, RCDC SAFE software. So we are going to cover all these topics. So that's why please like, subscribe my channel, and click on the bell icon so you will get the notification. Thank you. Thank you everyone.